Sorry. Good morning. Can you hear me? Awesome. Hi again. So my name is Dr. William Ogalo. I'm from Google Kenya, and I have a very twisted background. I began off as a pharmacist because I was trained as a pharmacist at Nairobi University, and after doing 2 years of pharmacy practice, I went on to do my PhD in Columbia University in New York, where I pursued health informatics. Then I came back. I joined IBM Research, where I did my computer science, healthcare and computer science as a means of solving global health problems for 5 years. And then now I joined Google just 2 months ago, where I'm using AI for food security. So I hope this is going to be a nice and interesting lecture, not really a keynote, but more like just introductory talk about what is AI, what can you do with it, what can you learn from it, and then how can we use this thing called Earth Engine that is offered by Google as a means for conducting analysis in different settings. Please pardon my cold. I have a small cold, but I hope you guys can hear me properly. Cool. So next. Yeah, so what is AI? I think you guys have probably heard this term many different times. And AI is essentially just a technology or an approach of imparting computers with like human intelligence, so the idea is to basically make machines and technology be able to act like if they are humans, or basically have the level of intelligence of a human in terms of like reasoning, learning, solving problems, and so on and so forth. It's become so inherent in different systems these days that it's going to be part of, like, the backbone of innovation in the next generation of computers. So it's really an evolution of, how things have been progressing over time. Now it's going to be like really one of the most important components of computer science and technology as we move on in terms of like scientific discoveries. It has different disciplines. So AI is not just the software itself. It's actually the hardware, the programming, the psychology of how to use these particular systems, and so on and so forth. So it encompasses like things like computer science, data analytics, software engineering, and so on and so forth. And this year, actually, it was interesting because of, I don't know if you guys remember about ChatGPT. Anybody knows about that? ChatGPT? All right. Because of that, there's like a huge buzz around like how to use AI for different things. And it happens that this year, it's actually the word of the year for the Collins Dictionary, as you can see from the small article down there. So what exactly is it? So again, it's an engineering task. It's about creating solutions and that involve human intelligence, right? In artificial products, right? And in between AI, there's something called machine learning, which is now the exact task of how to make the machine learn how to solve problems, right? And this involves training the machine using data and observations that have been recorded over time, and then seeing how you can learn from that data to see how you can get some level of intelligent computing from the machines. And then within that, there's something called deep learning, which is now even a more complex one, where the ChatGPT stuff is now currently. And that is really based on how you use what we call artificial neural networks that basically mimic neurons in the human brain and see how you can work towards processing information using those particular types of artificial neural networks. So how is this different from classical machine computing and compared to machine learning? So we find that classical programming involves writing instructions to a computer and telling it what to do explicitly, right? Think of a calculator, for example. It takes your digits as input. It has some rules about how to process the particular digits, and then gives you some given output, right? In machine learning and AI, it's a little bit different. What we're doing is you have data, and you have either labels or no labels, which means you can have like an output of interest, right? And then you train the machine to learn from the data, to infer rules from the data. Such as if you're able to see like new data, you can then infer what's the output given that particular rules that you learn from the particular model. And there are lots of benefits to AI. One of them is automation, which is really around, how do you make things go without human intervention, right? How do they make them go on without human intervention? And this has been used in different settings, mostly in factory settings, where, for example, you can have robots that look at how you identify defects in products, and so on and so forth. You can look at how you can reduce human errors, especially for tasks that are basically repetitive tasks. For example, like things like packaging or doing something routine like writing emails that are commonly sent to everybody. Things like that can be done by using AI that basically involves you to reduce, you are doing that because you want to reduce the chances of human error when you're achieving these particular tasks. Another thing is basically you can look at how to, let's say, for example, in factory settings where you're actually having a lot of human interventions, right? And they can be repetitive, right? So you want to use AI to eliminate that task so that you can have the humans do more difficult tasks, right? Things like writing, transcribing phone calls or looking at how to do surveys. You can actually make a machine do your survey for you. Then you focus on more intelligent things like, doing more reasoning tasks. And then you can think of how you can improve faster and accurate processing in data. So if you imagine that a machine can be way faster than human beings in processing information, this can be much useful in different kinds of settings. And then you can use it for, it doesn't sleep. You can leave it running on and on, so it can be available infinitely. And lastly, it can also be used to basically think about scale when it comes to R&D. You can think about how to accelerate different kinds of, processes when it comes to learning from data and discovering new information and new insights from different kinds of data. So in terms of applications, I think you guys have known more about this in terms of in agriculture, but this is more in general. So you find that AI can be used in different contexts, right? Things like voice recognition, image recognition, translation, predictive modeling for floods, dynamic analytics for different kinds of reasons, like in this case, visual inspection, and also cybersecurity, where you can look at how you can basically improve, scan for threats that are going to affect your computers and different kinds of networks that you use in computing. Can I get some water, please? So different kinds of things that can be used for different reasons in computing science and different kinds of domains. And more importantly, we find that you can use them for specific use cases, right? So for example, here, we're talking about forecasting of floods. How can you do that in a given use case? So here is an example where we get from Google Research. And the idea was to look at how can you forecast riverine system floods in rural areas, right? Right now, what they do is that somebody will come with a tool and they would measure out the depth of a river to say whether or not the height is increasing of the river, right? And then they can transfer that information as a flood warning or potential flood warning to other kinds of users or other people by word of mouth, right? But oftentimes if you do this, you end up being very late, that you don't get time to act as if you can prevent the given flood. Sorry. So what we did is that instead of doing this, we want to be able to impart the ability to predict 7 days in advance the risk of a flood in a given riverine system, right? And what you do in this case is to model what we call a hydrological model, which is essentially using things like weather data, temperature, precipitation, and so on and so forth, to look at how likely the depth of a river or the volume of a river will increase in 7 days in advance, right? Then from there, you can also look at how you can model the flood risk in a given plain or a given area by using what you call inundation models. So here we are basically doing what we are saying, look at how it can spread on land and look at how deep that spread is going to be on land so that you can tell exactly how bad the given flooding will be. And from there, you can distribute your information to different kinds of users, mostly stakeholders, but also like end users, like individuals or basically the public masses. And by doing this, you can actually prevent the risk of flooding by almost half. The impact of flooding by almost half by having guys act in time to prevent these kinds of flooding incidences. Now, we know this is important, but there are also challenges to deploying of AI. One of them basically is, you think about your use case, right? You just don't come and say, I'm going to do it for any kind of problems. It won't solve some problems. You have to think about what exactly is important for you and how you're going to solve it in terms of using particular AI methods. Secondly is that there are not many people who have done AI worldwide. About only 10,000 people are purely skilled in developing AI methods, and that's actually a very, very, very big problem, which means we have to think about how to use the right experts, get the right people who can develop the systems and also deploy them. But more importantly to me is exactly the data. The data is actually the most important reason for, the biggest challenge in AI, because it's often scarce or hard to use in different domains, right? So you find that, there are different kinds of types of data, imagery, text data, structured data, and so on and so forth, that can be very hard to use in terms of, how to employ them for machine learning and AI. And lastly, deployment, where you deploy them, how they're going to be deployed, who will use them, how they're going to be used, and so on and so forth, is important to consider when you're thinking about like AI solutions. But we know that historically, this has been something that's been going on and on. But more importantly, right now is that we've now realized that AI, as I said before, is now becoming inherent as part of businesses, and it's going to be part of business intelligence as we move on in the new era of technology. So we won't run away from this. We need to figure out how to embrace it in the right way and think about how we can essentially make it augment our intelligence as human beings so that we can be able to get the right impact of the AI solutions. But again, we have known about the fears of AI, right? We know that people are talking about it can cause doom to the world and so on and so forth. So what we think is that every person who develops these particular systems should think about some core principles that guide their development of these AI solutions. So for example, at Google, we are basically enforced these rules that we see on the chart here that essentially tell us how we can develop AI. So basically they're called the Google AI principles, but can be applied for other people, but at least it governs how Google develops these particular AI solutions. So one is that it has to be beneficial, right, to anybody, to everybody. It has to be free from bias. It has to be basically safe for use. It has to be accountable to people, right, and their data. It has to be informed by principles of privacy designs, and also it has to be basically relying or dependent on or driven by scientific evidence. And lastly, it has to be available for use that accords with these particular principles. So you don't make it and shelve it, you make it available for people to come and use it and basically have a way to critique it and think about whether or not they like it or not, right? And also, we do not want to develop these tools that can cause harm. We don't want to cause injury, or we don't want it for use for things like intelligence or surveillance for different kinds of countries and so on and so forth. And also, we shouldn't be able to contravene laws that exist for these particular use cases. So that's a very, very, very brief intro to AI. And now I'll move on to Google Earth Engine as a solution. So the Earth Engine is basically a geospatial analytic tool that combines data from different kinds of satellite imagery and other forms of data with what we call the Google Cloud Platform, right? And the first goal of this tool was to basically think about how to have this geographic data be able to analyze, to be able to be analyzed, and also to be computed at scale. So think about large-scale planetary data from all over the world, all over the globe, and how this can be used to infer from visualizations and also analysis. And then number two was to basically think about how do we solve global challenges by progressively improving our abilities to analyze these particular large-scale data sets that we provide from different kinds of sources. So how does it work? Again, we have different kinds of data, as you can see from there. Tabular data, time series data, so on and so forth, mostly, and also imagery data that you can see from below there. So satellite images are basically much more common today. Different kinds of data are being collected by using satellite images. And then from there, you have some means of computing this, analyzing the data, using these particular tools like machine learning, AI, and so on and so forth. And then from there, you can then visualize the output of your data as well as your graphs in terms of images and graphs, and then use that for particular insights for different kinds of problems. So why do we use Google infrastructure? It's because it enables you to basically consume large amounts of data and process that particular data. So that as an individual, as a person, you don't have to worry about these particular aspects of basically processing the data or downloading the data and so on and so forth. You just think about what am I going to analyze for my work? What do I need to, what's my question? How am I going to solve it using Google Earth Engine without having to worry about where the data is from and so on and so forth. And there are two main components. One of them is the data itself, the catalog of the data, right? And this includes things like climate, weather data, climate and weather data, satellite imageries, and also just geophysical data. On top, there's basically an example of what we call climate data. So that's actually the temperature of the globe. It's like the movement of the clouds. In the middle part is, you see, it's like satellite images of a given area or a given point in time. And the last is basically the shape of the land cover itself, or land mass or terrain, as you can see in the last picture there. And also beyond this, we have about 40 years of data that can be found in the toolkit. And you can also come with your own data and then onboard it into the particular system for your own use. The platform itself is basically a simple UI that can be used to analyze these kinds of data. As you can see from the top there, it's just a way to interact with the data and visualize it and basically perform machine learning tasks on the data. You can also use something called Python, or I don't know if everybody knows about Python or JavaScript as a means of analyzing your data. So you don't have to use the UI itself, but you can actually use API calls to analyze the data that you have in Google Earth Engine. And the most important thing is that it is able to support multiple users because of what we call parallel computing and scale. So you can have thousands of users using the same tool at the same time, so you don't have to worry about compute or time speed and things like that when using the Earth Engine. And then lastly, we have a huge community of users who can basically provide support about different kinds of problems and solutions on how to use the Google Earth Engine. An example here is how it's being used for removing cloud cover and cloud shadows from Earth images, right? So you can imagine you can have a series of snapshots of images for a given area, but you can have them at different times of as you go on, right? And this will basically enable you to have different views, including some with clouds, some with not clouds, and so on and so forth. But if you want to have the actual exact look of the surface itself, you go to the next step and use these particular tools to remove the clouds in some format, so that you can be able to basically get images that look like from this, as from compared to the one before from there. So with this Google Earth Engine, we have lots of land use, land cover data sets that can be used for different kinds of use, or different kinds of reasons. You can use them for predicting climate risk. You can use them for looking at how to protect forests and other resources, looking at carbon emissions and the impact of things like deforestation and so on and so forth, and also looking at how you can basically have sustainable world in terms of global supply and chain transparency, as looking at how people let's say move around places or buildings and so on and so forth, how they cause deforestation and things like that. So there are many different kinds of uses. I'm just going to show you examples of two of these uses, right? And the first one was done by the European Commission, where they looked at how do you map the global surface water in the world, right? So this is a global scale surface water project that they looked at a few years ago. And they looked at about 3 decades of data, right? So about 30 years of data that was analyzed from this thing called Landsat images or satellite images. And then from there, they basically mapped out the flows of water at different points in time, right? And surface water in this case. And then they can use this for different kinds of tasks, for example, looking at security of water, flooding risk and impact assessment, and so on and so forth. And the second case study is sort of what's done by the Food and Agriculture Organization. And the whole point here was to analyze plots of land in a given area, right? The idea is basically look at images, look at how the land is being used, how it's being forested and all that, and how it's being taken over by human activities and so on and so forth. And this has been used for looking at deforestation, land use changes, and so on and so forth, as well as looking at how to report the greenhouse effects or greenhouse gas emissions from different areas of a given location. So with all this, I hope you've learned something small from about what is AI and Google Earth Engine. I spared more time so that you can have a discussion with the team here, and then just see if you can get something from the talk. Thank you so much.
Thank you so much, Dr. Harry. We appreciate. I think for me, my appreciation is the visual effects from the presentation. The tech part of it, I may not be quite in it, but the visual. And the challenge is, even as we are engaging our leaders, our decision makers, this presents an opportunity to be able to have a buy-in, true. So sometimes when you make presentations, they're very oral-based, but when you start to subject our leaders to the potential, the trends, what has been and what is likely to be, this then becomes very important. So for those partners who are quite, this is their strength, looking forward to those engagements. So I'll allow a few questions before we move to the next presentation. I'll actually give three hot questions. I haven't even said go. And then we'll move to the next presentation. But it doesn't mean we can't engage at coffee break or tea break, even as we engage in the marketplace. So raise your hands right now so that we have them set. I have one here, the gentleman at the, almost at the back. They're all men. So 1, 2, 3, done.
So good morning. My name is Charles from the Kenya Space Agency, and great presentation there. I wanted to ask, you mentioned two things that caught my attention, the people and the data. Are there efforts that Google is making to deepen the personnel that is available on machine learning? And then on the element of data, machine learning systems or models require a lot of data. And there is always the assumption that the AI will solve most of our issues. But if we don't have data, and especially in Kenya and also the region, we have a lot of gaps in terms of the data. How do we address that as we move forward? Thank you.
Thank you. So those are very good questions. The first one is around like personnel and human resource and what Google is doing about it. I think it's not just Google. There are lots of companies that are coming into the country right now, in Kenya in particular, to look at how you can improve the skills gap around AI and machine learning. We personally have different kinds of programs that basically train non-Googlers about machine learning and AI, data science, and so on and so forth. The idea is basically you have like things like code camps, boot camps, hackathons, where you can come and expose a problem, they come and learn how to solve the problem, and have their own solutions basically deployed or whatever they want to do it, in terms of like, where they are having impact or where they're having interest. So we have different fronts. We can employ people. I'm not saying that we're going to employ now, but I'm just saying it employs local talent, like Google employs local talent like myself. And also it also has a way of growing the local talent without employing them by basically imparting knowledge and skills about AI. The second question is around data issues or inefficiencies, and it's a very important problem in machine learning. As we said before, if you don't have the right data, then you're not going to make the right information. As we normally say, garbage in, garbage out, right? For sure. But with AI, you find that there are different ways. First of all, you have to look at how to get more data. And that's why I think there's a talk about collaborations later on in the day about how to collaborate and get more data from different kinds of people, right? And then number two is basically how do you use new technologies to look at how to handle inefficient data, right? One way is like if I can learn from your environment in a given area, I can infer how likely you are just by knowing that I'm surrounded by these particular regions in a given area. So if I'm looking at rainfall patterns in Kericho, for example, I look at the surrounding area. If they don't have the data for there, then I can infer what is the rainfall patterns from Kericho. These are new ways of how to address this inefficiency, but it's not really there yet. We are still thinking about new and better ways of handling things like bias in the data, inequalities in the data, things like transparency of these particular models, and so on and so forth in the tasks.
I think I was next.
Oh, sure. Go ahead.
Hi, I'm Oscar Bruford from IDH. I'm curious about what some of the next, let's say, short-term developments that are on the map for you for the Google Earth Engine.
Okay. It's pretty interesting. So still scaling is important. There are different kinds of projects. It's now open to the public, actually, right now. So it is so use case driven in a way that it depends on who is using it, right? For us, I think we always think about computing at scale. So we want to think about how to make it more powerful. It's still, I think, if you use it now, you could find that you might have some few gaps here and there, but if it's still very okay for like a massive usage. But I think that's the most important thing. How do you make use of better compute? How do you look at large language models, things like foundational models for that, basically looking at geospatial data? That's where we are going towards. So technologically, it's improving the compute. And then from the AI perspective, it's more of like looking at how do you get these new technologies like ChatGPT for images and all that in a way that, in a very simplistic way. So they're called large foundation models for geospatial data in this case, yeah.
Okay,
Yeah.
thanks.
Thanks for a great presentation. Claude here. So we are seeing the data legislation landscape of many African countries grow. Countries are stepping up. And I was wondering whether you can speak to how you're working with governments who are now putting in place laws that cover things like data localization or data sovereignty. How are you addressing that? And how do you see this space grow over the next decades? Thanks.
Yeah, that's a very good question, and it also ties back to
Daktari, just a minute. Let's have the other question.
Okay.
Please, do you have someone to write it down?
I'm good. I'll remember that one.
My name is Bangu from Waziri City Laboratory Board, Tanzania. I've got two simple questions. Number one is with AI. Mostly, I'm a friend of AI and I use it most of the time. But I'm just wondering, when is it going to be able to, process some of big information, like if you want to get some digital diagrams, etc. Apart from just text that is available now. And the second question is with Google Earth. I think I like the engine, but I probably want to know, is there an app for that, and how is it easy to access, and do we need to subscribe or something in order to get more useful in our daily activities? Thank you.
Okay, thanks. Those are very good questions. I'll begin with the first one, which is around legislation. So every software company has interest in whenever they come to a given region, and that means that everybody has to have a way in which there's a level playing field for everyone. That's why it's important to have these forms of legislation around privacy, protection, reuse of data, and so on and so forth, security of data, and things like that. And at Google, we take that very seriously as a company, and we actually have a whole department called Public Governance and Policy that is basically lobbies for things like the appropriate legislation in a given country, how to advise the government to create, list these policies around legislation and how it impacts business. I know the same thing happens with other companies like Amazon and Microsoft. They have interest in basically ensuring that they're playing by the rules that the government has provided, right? And that's the most important thing for the big techs. For individuals, I think it's more of think about whatever you have data, think about do I have approval to use it? Do I have access to it by, is it publicly available or not? And am I using it the right way? Am I being fair when I'm using the data? So it's more from an individual perspective, but again, it's really dependent on what's available in a given location. What I know is that our countries in Africa are not very well advanced in these policies, and legislation around data. So what we tend to do is to use principles from the West, right? For example, for healthcare, there's something called GDPR in Europe that basically prevents you from sharing any forms of data without the consent of the individual. And so we tend to use that as a benchmark for local context without actually having the local law required by Kenya, to do that, right? So there are some ways you can infer from other countries or other parent company regions or countries that tell you what to do, despite what the local governance and laws are. So I think we are bound by some obligations about Google that basically will make us not just misuse data in any form, regardless of whether or not a country has got the laws or not. That's normally how we approach it. And then you talk about AI and how you've probably used ChatGPT and so on and so forth, mostly text-driven. So there are other forms of AI, mostly for images, for videos, for structured data, and so on and so forth. They are typically not surfaced yet to the masses, so maybe that's why you've not found it easy to use, but they're typically there. So you just need to do more digging, looking at what's available for use. Things like DALL-E, I don't know if I heard of DALL-E, for images and getting new images and so on and so forth. There's other forms of, like basically machine learning models that are more old school that are normally available online. And you can use them. Text transcription, these things are they're almost like, they're almost ubiquitous right now, like voice recognition. If you use YouTube, I would recommend your videos, that's like AI going on, it's happening right now. Things like your emails, if you do autocomplete, that's AI in action, and so on and so forth. So there are ways so that you're not seeing it because it's ubiquitous, but it's really, really there. And then number 2, Google API, there are 2 versions. There's a public version that you can basically just log in and use. I can provide the address after the talk. And also you can actually subscribe as an entity or as an individual to access even better functions from the API tools and so on and so forth.